So module number 2 is regular expressions and languages. Inside this you have regular expressions, equivalence of RE and FA, Arden's theorem, RE applications, regular language, closure properties of regular language, decision properties of regular language, and pumping lemma for regular language. All these things we will be studying inside the module 2 of the subject theoretical computer science. So learning objectives: to understand the concepts of regular expression, to learn commonly used operations involving regular expressions, to discover how to efficiently write complex regular expression using a step-by-step processor. So what is a regular expression? A regular expression is a sequence of characters that define a search pattern, mainly for use in pattern matching with strings or string matching, that is find and replace like operations. Regular expressions are a generalized way to match patterns with sequences of characters. It is used in every programming language like C++, Java and Python. So regular languages are used in almost every programming language. They are nothing but a way of representing a set of characters. Characters can be alphabets, can be digits, anything. So they form a matching with strings or string matching, that is find and replace like operations. So finite automaton. What is finite automata? A finite automaton can be represented by a phi tuple where Q stands for a finite set of states. So in a tuple you have a finite set of states. So this is something which will come, which you will understand in module 1. So suppose this is there. This is a phi tuple. Finite set of state are Q1 and Q2. In this you have Q1, Q0 and Q1. Then the sigma is a finite set of symbols called the alphabets. So we say that summation is nothing but, or sigma is A equal to B. So we say that it is alphabet A over alphabet A comma B. Then delta A is transition function. Q0 is the initial state from where any input is processed. Q0 belongs to Q. That is, it belongs to the set of states because Q0 is also present in the set of state. F is the set of final states. F belongs to Q. Again, F also belongs to Q. Final state we represent it as circle inside a circular. So if we represent like this, then Q1 we say is a final state. Q1 we say that Q1 is a final state. Regular expressions. It is a method to represent a language L. Regular expressions can be written from regular languages. So what is a regular language? The language which is accepted by a finite automata. Language is a collection of strings. So language is nothing but epsilon. What is epsilon? Epsilon is nothing but a null string which has no letters, no alphabets or no characters. We say that it is a null string. It is an epsilon string. A is a language, AA is a language, AAA is a language, 4 times A is a language, and so on. What is a language? It is a collection of strings. So string can be 1 string, it can be 2 string, it can be more than 2 also. Regular expressions. There are 3 operators used in regular expressions: union, concatenation, and clean closure. Closure has a highest precedence followed by concatenation followed by union. Highest precedence means higher priority. We say that closure is always having the higher priority. Closure followed by concatenation priority wise. Third comes union. So what is union? If R1 and R2 are regular expressions, then R1 union R2, also written as R1 plus R2, is a regular expression. So if R1 and R2 are regular expressions, then R1 union R2 or R1 plus R2. When we say union means what? Suppose there is a string. Set A contains elements A, B. A set B contains elements C and D. And if I say find the union of A and B, so A union B will be all the elements of A and all the elements of B is nothing but union. Concatenation, if R1 and R2 are regular expressions, then R1 R2 means R1 followed by R2 is also written as R1 dot R2 is also a regular expression. L of R1 concatenated with L of R2. And what is clean closure? If R1 is a regular expression, then R1 asterisk, the clean closure of R1 is also a regular expression. R1 asterisk denotes 0 or more occurrences of R1. So suppose there is A star, then what will be the clean closure? One will be epsilon. Epsilon means 0 occurrence of A. We say 0 occurrence of A is epsilon. Then we can have single A, 2 times A, 3 times A, 4 times A, and so on. Now, regular expressions are used to denote regular languages. So if X is any character, then regular expression X stands for the language X. That is, L of X is nothing but in bracket X. Note that this language is a set that contains one string. The string has length 1. Epsilon is a regular expression, indicates the language containing an empty string. So epsilon means 0 occurrences of that particular alphabet. So we say over alphabet A and B, so 0 occurrence of A and B. Epsilon means null or empty string. It is a regular expression, empty language. When we say empty language is not epsilon. Epsilon is an empty string. So language has a empty string, that is epsilon. When we say that the language is empty, we say it is a null language. So we represent it as bracket. So that means there is nothing in that language. When we say language equal to epsilon, means a null string is present in the language. And we say that when the language is empty, then denoted by curly braces. Null string is present in the language denoted as epsilon. Language is an empty one, nothing will be represented, just curly braces. So summary, we say an expression is regular if you have the expression is a regular expression for a regular language. Then again, this is a regular expression for a regular language, epsilon. If A belongs to summation represents the input alphabet. A is a regular expression with language A. A plus B is also regular. AB is also, so A plus B we say that it is a union. A into B is concatenation, and A star is a clean closure, which means 0 or more occurrences of A. So first example is language is given. Now what does this represent? Epsilon represents a null string. So your regular expression will be A star. A star means epsilon and any number of A's. So it will be 0 or more occurrences of A. Let's see the next example. Here, what is the difference? Epsilon is not present. When epsilon is not present, we represent it as A plus, means clean star. This is clean star. Clean closure means A with a asterisk. What is the difference between A with a asterisk and A star? The difference is that this has epsilon. This does not contain a epsilon. Write a regular expression for a set of strings over 0, 1 that end with 3 consecutive ones. So language will be 1, 1, 1. So here it can be an epsilon and 1, 1, 1. So we will not write epsilon, we only write 1, 1, 1. Then you can have 0, 1, 1, 1. You can have 1, 1, 1, 1. So in the end, what you need? In the end, we need 3 ones. In the end, we need 3 ones. We can also write 0, 1, 0, 1, 1, 1. In the end, you have 3 ones. So how do you represent this language? In the end, we want 3 ones. So 1, 1, 1. And before that, you can have any number of zeros and ones. So we write 0 plus 1 star. Any number of zeros and ones, but in the end, you need 3 consecutive ones only. Write a regular expression for a language starting and ending with A and B, having any combination of B's in the between. So it should start with A. In between, it can have any combinations of A and B. A, B, B, B. A, B, 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 and so on. Between any combinations of B, it can have starting with A, ending with B, starting with A, ending with B, starting with A, ending with B. This is your language. So regular expression will be A should be the start, B should be at the end. In between, you can have any numbers of A and B. So the AB also can come in this, because if there are 0 B's in between, then AB will also be accepted. Write a regular expression for language accepting all strings which start with 1 and end with 0 over alphabet 0, 1. So starting with 1, so language will be starting with 1, ending with 0. And in between you have 0 occurrences, that means in between there is epsilon. Then you have 1, 0, 0, 1, 1, 0, 1, 0, 0, 0. So in the start you need 1, end you need 0, start you need 1, end you need 0, start 1, end 0, start 1, end 0. So how will you write? Start 1, end 0, in between any number of zeros and ones. This will be your RE, regular expression. This you can try. Write a regular expression for a set of string that ends with A, B, B. So how will you do this? We say that language is equal to A, B, B, ending with A, B, B. It can start with A, end with A, B, B. It can start with a null string, that is nothing it starts with and only ends with A, B, B. It can start with B, ending with A, B, B. It can start with A, B, ending with A, B, B. So this will be the language. What will be my RE? RB will be A plus B star. So asterisk, not star, asterisk. Why asterisk? Because epsilon is also accepted. Here in this case it was epsilon, but it should end with A, B, B. Let's see the next example. Write a regular expression for a set of all strings starts and ends with different symbols. So suppose it is starting with A. In between you can have any number of A's and B's, ending with a B, union. Starting with a B, in between you have any number of A's and B's, and ending with a A. So this is your answer for starting and ending with different symbols. Thank you.